Hi, today I would like to show you one special IDEA StatiCa connection. It's about two members which are going parallel in a distance of 1 meter, and they should be connected to a concrete column. We will use stiffening member and stiffening plates for the modeling. My name is Ivan Beleš and I am support engineer for SCIA and IDEA StatiCa. Now we are in IDEA StatiCa and we have these two members, M1 and M2. They should be connected together with a third member, and this one will be connected to this concrete column. This is the task for today. I will create a completely new connection and we will start with one empty model and input everything. So we start with these members. This is already in the project, so we create only a new position in the present project. I will move it 500 millimeters to the right, copy this member and move it 500 millimeters to the left. So we have these two members. You can ignore this support because after we will add the anchors for the concrete column with the concrete block, this support will be deleted or removed from the model. It will be not necessary. So we need to connect these two members and we need loads. We have only one load case with minus 50 kilonewton shear force. It's also necessary that you check the position of the forces. Where is your 0 point? At the moment it's here. This is my position, and if I create the forces and I check the forces, then here is the 0 point for the bending moment. For us, I will move it 240 millimeters to the right. You have to check your analysis software where you have the 0 point of the bending moment, where you want to have the center point of the connection. So I will move it in X direction for 240 millimeters and this one also. So now we can check the forces, and they are going somewhere here. We will have here these two head plates to connect them to the column. So now we need the connection member, and we use the operation stiffening member. Stiffening member is used if you want to transfer forces inside of the connection from one member to another member. For this task, don't use the external members. External members are the members, they are in your analysis software and they get internal forces. If you have something inside of the connection, use this stiffening member. There is also one good practical reason. If you have a standard member, you can cut it only from one side, but the stiffening member can be defined in the length in both directions and you can apply operations from both sides. So we want to rotate it. I will check the direction, not this one, and look from top view. Okay, 500 millimeter in one, 500 in another direction, and in X direction, I don't know, 250, 500, I think. Okay, this is our member. The customer connected this stiffening member to the main members only with one cut operation, and it was welded together. I will show it to you and then we will use another operation to show. I will show why. So we will simply cut the SM1 with the M1, so I can activate the member names with M1, not with bonding box, with surface. So it's connected. Only this weld will be automatically changed to one CJP weld. So we can do it on the opposite side. Connect with M2 and it works. This is not an issue. But I don't think that this is a good practical way. Also, the customer probably have it only in the draft picture. I would say we should use some bolted connection for the assembling on the building side. So therefore, I will delete them. And we can use this shifted end plate. Okay. What we connect? SM1 with M1. And this works. But if I want to connect it on the another side with M2, then it will not work because it's on the opposite side, because this member is going in this direction and it's each time in this direction. So this is not the way we can work. Can delete it. What can we do? I change the length. I hope I am on the right side. Okay. This is only a half of the member. And we can copy it and simply rotate with -90. And then I can copy this shifted end plate and connect SM2 with M2. And then it works. SM2 with M2. So it works. But they are at the moment not connected. We can connect both together with this operation. This is SM1 with SM2 with metre cut. And then we get here welds. These are these CJP welds. They are like this contact glue. These welds have no own stiffness. They will be also not checked in the analysis. This is simply a connection of two materials. And therefore we will not introduce some stiffness which is not really in the connection. This is simply they are connected and glued together. So we can use them. This work. What we need are ribs in these stiffening members. Right mouse button, new operation. Rib is one of the simplest operations. So we will put it in SM1 and relate it to nothing, only change the position -125. So they are on both directions, both sides. I need to extend, but I need to extend only one side, which is not possible. If I change the width to 250, it will be extended on both sides. So therefore, I go to location on rear. And I think it's not important, we can say lower, but we have only one connection, one rib, so it doesn't matter. So this is the first one. I can copy it to the SM2 and change the side to front. So we have two of these ribs, and now I can copy this one, delete the width to 0 and change from rear to front, and this one can be created as a copy, again without width from front to rear, and we have all these ribs implemented. So we have used stiffening member, and now we need the operation stiffening plate. I have tried to position or place this stiffening plate on one of these operations, but I was not successful. Therefore, I will simply change the rotation. I hope this is the right direction. Okay, 250, 250, 200, 200, and thickness 30 millimeters, and we will move it in X direction with 200. Oops, this is rotation. 250 millimeters. So we have collision. This is not an issue. Why? Because we anyway need to weld these ribs to the plate. And if you create a position correctly, then you have to add new welds. And to add welds is more complicated to add the plate cut or cut of the plate. And this cut of the plate, we will also add the welds into the connection. So we can do it. plate cut, and we want to get, so jetzt, I don't, jetzt, it's German, sorry. We need to connect this plate. I don't know the name. You can hover with the mouse over the plate, and then you see the name of the plate in the left bottom corner. It's Stiff 1. You can also click on this arrow and select the plate and say second plate. This will connect it with this one. It's automatically connected. What we need is double field weld. And now I can copy it and change to stiffening 2, and it's connected. We can copy this SP1 to SP2 and let's say change the position. This would be the simple way. But if I change the thickness of SP1, then I have to move also SP2. Therefore, it is each time better if you place the operation on the position of another operation, previous operation, and then you can simply change the thickness, move the plates, and everything will be moved with it. So the origin is a plate, is the SP1, but it's not a rib, it's a doubler, and we only have to change the side and deactivate the welds. And now we have automatically placed SP2 on SP1. If I change the thickness of SP1 to 20 millimeters, then it's automatically changed. 30 millimeters. Now we need this concrete column. The operation which is usually used is this base plate. It's base plate. How is the name? Base plate, yes. But we already have a plate and it should be not horizontal. Therefore, you can use bolt grid. In the bolt grid, you can change the type to anchors, and then IDEA StatiCa automatically creates a concrete block. If you don't say that you want to use some existing block, but we have a new block. What we connect, we are connecting two plates. This is the first one, and this is the second one. The type is M24, but the block is on wrong position, so we have to change the position of the block to SP2 and check the side. Sometimes it's going to the right, sometimes to the left side, depending on the way how you define it. So that's done. Only the length is not correct. This is also a standard question on the hotline. If you have a concrete block, you can adjust each side, the distance on each side separately. Simply stay with your cursor on this offset or on some text and you get description. We can use 1 value, 2 values, or 4 values. So we can use 4 values. 1000, 1000, 100, 100. So we have the dimension. And we need the anchors. They are shifted with 50 millimeters. Now they are in center. I can move them rows 175, 125, and on the another side, on the opposite side, minus 125. This is with the bolts. You can use semicolon or you can use blank. If you use blank, then it's a relative distance from the last row position. So it goes back 125. So we would need to go here to 250 minus 250. Or you say, I go from the center each time to the right and to the left. The same top and bottom, 175 and minus 175. Maybe 185. Okay, this is better. We cannot calculate it. Why? Because so the length, let's say 400 millimeters, and we have higher shear force, and for this short distance we would get an issue on the side. Therefore, I need something different to transfer the shear forces. Here is friction. This is for standard column. You can try anchors if you have some lower forces, but we need a shear lug. I have prepared this IP 140, let's say 200 millimeter length, and we rotate it for 90 degree. What I need to change is the thickness of the size of the weld, because this is usually for this IP too small, so I change it to 4 millimeters to don't get some issue with the construction rules. Okay, everything is done. We can save and run the calculation and look if we get some instability or some another message. So everything is okay. Of course, I have prepared it. And we can check the, let's say, the stresses with mesh, with deformed, and you can scale the deformations, for example, with 40. So then you see the deformation. So thank you very much, and maybe we see us at next video. Bye.